Welcome to TutySpot. In this video, let's discuss about ambiguity in context-free grammar. So what is this ambiguity? An ambiguous grammar is the one that produces more than one leftmost derivation or more than one rightmost derivation for the same sentence. Or a grammar that produces more than one parse tree for the same sentence is said to be ambiguous. This parse tree is also called as derivation tree. It can be either leftmost or rightmost. Anything is considered. Here in this ambiguous grammar, the parse tree producer can be either both parse trees can have the leftmost derivation, or both parse trees can have the rightmost derivation, or the combination of both left and rightmost derivation. That is, one is left and the other is right derivation tree. Usually, we have three rules to obtain the derivation tree. First is the root node must be a start symbol. Second is internal nodes are non-terminals. That means uppercase letters. And the third is leaf nodes are terminal nodes. Means child nodes have to be in lowercase. Let's see an example for ambiguity. Let's consider the grammar E produces E plus E or E into E or minus E or within the parenthesis E or ID and produce the string ID plus ID into ID. So with this grammar we can construct two parse trees to produce that string. Let's see the derivations for the trees. Then based upon the derivation we can construct the parse tree. Consider the production E produces E plus E and take the leftmost derivation. Here in each step leftmost non-terminal is expanded first and we have to derive only one non-terminal in each step. So first E produces E plus E. Then the leftmost E is converted into ID as E produces ID according to our production. In this grammar E produces ID. Then next the non-terminal E produced E into E as we have the production E produces E into E. Then both these E's produced ID one after the other from left to right, one in the each step. This E produced ID and later in this step this E produced ID. So the required string ID plus ID into ID is obtained. So we can construct the parse tree with this. In the second derivation the same process occurs. But in the first step we took E into E for the first non-terminal E. So the production is E produces E into E. Then the leftmost non-terminal E produced E plus E. Then in the further steps all the non-terminal E's produced IDs from left side to right side of the derivation. So here the required string ID plus ID into ID is obtained and we can construct the parse tree. Here we can draw both the parse trees as leftmost parse trees. So in the first parse tree we have the root node as E and took E produces E plus E. Then from E we took E produces ID production. Then coming to the right side of E produced E into E. Then again the leftmost production E produced ID and then the right production E produced ID. So our required string is obtained ID plus ID into ID. Next in the second parse tree we have the root node E, then took the production E into E. So now we have to get plus. So in the next step we took E plus E production for this leftmost node E. Next E produces ID for all these E's one after the other step from left to right node. So the required string ID plus ID into ID is obtained. So the above grammar given two parse trees. So it is considered as ambiguous grammar. This is all about ambiguity. Thank you.